Okay, so say you have some vector, a position vector, okay, and we'll call that V. And then what we want to do is we want to think of it in terms of x and y. So if that's the terminal point, x comma y, we can say our vector V is equal to xi plus yj, remembering that I and j are vectors. Okay, so think about there being this right triangle here then, in terms of x and y. So you could say, and then there's a theta, right? Okay, so we'll put theta in here. And that theta is coming off the horizontal axis, okay? So it's rotating that way. So we can say, here's my x, or here's my y value, here's my x value. And so I can say the sine of theta is equal to y over. Now I'm going to think about this being the magnitude of v, because I want a real number here. I want to know that distance, okay? And so I get that, or I can say y is equal to the magnitude of v times sine theta. And then similarly, you can do the same thing with x. So the cosine of theta is going to be x over the magnitude of your vector. And so x is going to equal the magnitude of v times cosine theta. So when you want to put it in your vector in I plus j form, in terms of I and j, and you want to use the magnitude and the direction, then it's going to look like this. So your vector v is going to equal x, okay? So magnitude of v cosine theta times I. Now, I would like parentheses here. I noticed in the book they didn't put the parentheses in, but I think it makes it a little clearer to see. It's the cosine of theta, whatever that is, times that unit vector for I, plus, and then you're going to have magnitude of v sine theta j, the j vector, okay? So this is what you want to remember, but that's where it all comes from. Now, in example 13, it says write a vector with length 7. That's the magnitude then. That is this. They're telling you the magnitude. They're not making you figure it out. That's kind of a crazy little arrow I have going there. All right. And an angle of 135. So that's our theta right there. And that angle is coming off the positive x-axis. And this is in terms of magnitude and direction. So now we're going to write that vector. So the vector is going to equal 7, because they already told us the magnitude, cosine 135 degrees, times vector I, plus 7 sine 135 degrees, j. So think about where 135 is. That's supposed to be a V. It's not a very good V. Okay, so 135 is in the second quadrant, right? That's 135. And it has a reference angle of 45 degrees. So you're going to think about the sine and cosine for a 45-degree angle, square root of 2 over 2. In the second quadrant, cosine is negative. But sine is positive. It's like we're putting everything we've learned, in the last little bit together here. Okay, so just writing it a little bit nicer. We're going to have the opposite of 7 square root 2 over 2 times the I vector, and then plus 7 times the square root of 2 over 2 times the j vector. Okay? And that is that.